Last class, we dealt with many steady systems. Today, we'll look at unsteady systems. In steady systems, nothing inside the control volume changes with respect to time. For unsteady systems, the situation becomes much more complex, as many things can change, including the mass inside the control volume or even the control volume itself. For steady analysis, there were not many situations where we had to track the mass, but for unsteady analysis, it is something we definitely need to make sure is being conserved. This can be done many ways, a couple of which are shown here. Basically, the net difference of whatever is coming in and out is the overall change of mass of our system or control volume. Of course, we also need to perform an energy balance on the system, just like we do for any system. Again, this is slightly more complicated than the last video, as unequal amounts of energy may be coming in and out in unsteady systems, so this needs to be tracked. In general form, the change in energy of the system is equal to the difference in the energy in and out. The left side here encompasses not only everything we dealt with in the last video, heat, work, potential energy, and kinetic energy, but now also any mass flow energy. And last video, the right side of this equation was 0, and now it may not be. There are, however, a couple situations where we can simplify the analysis somewhat. One of these is uniform flow. In these situations, the fluid properties do not change at the inlet or outlet. Then we can use the average properties at the inlet and outlet to simplify the analysis. We then have conservation of energy, taking into account everything coming in, heat, work, and flow energies, all the same terms coming out, as well as the changes of energy inside the system, as seen here. A lot of times as well, the changes in potential and kinetic energies can be neglected. In this case, the equation is simplified into the versions shown here. That was a lot of generalized information. More insight can probably be gained from doing and or seeing some examples. On that note, here is the pre-lecture example for today, as well as the answer. If you have any questions, please bring them to class and we'll see more examples of this.